We were working through our solving cubic solutions, and I got kind of hung up in the last video trying to solve this question, and I noticed that there was something wrong because as I was going through, and most of my work was actually pretty good, but I had a transcription error. And so when I got down to this stage and looked for my roots, I had actually written +1 here instead of the original factor we found, which was -1. So I ended up finding a root of -1 instead of +1. Now the reason I knew there was a problem is because I wanted to test with the y-intercept. And I found a y-intercept by putting 0 in for all of my x's. I found my y-intercept should have been at 0, +12. And with the roots I was getting a negative y-intercept. So I knew something was wrong, but I couldn't figure out what. And I had to go to Desmos to figure it out, and I couldn't find it, until I looked at Desmos, and I realized I actually had just done a silly transcription error. So that's a strategy I use as well, testing y-intercepts to just check my work. Okay, anyways. So, and then, to make matters worse, what a gong show. After that mistake, and after finding Desmos, I was having trouble finding the video on my screen again, and so I accidentally disconnected the camera. So the last 2 or 3 minutes of that last video are for certain a gong show. Anyhow, we have a nice sketch, we're happy, we resolved any issues, and now we're ready to move on to the last 2 questions that are for practice, which is 4B and 4C. All right. So I hope you learned from that if you make small mistakes, that is something that definitely happens to us all from time to time. And what's important is that we believe that there's a way we can get through it. So we got 6x cubed minus 11x squared minus 24x plus 9. Now, the first thing we'll do is list all possible rational roots. Now, you don't always have to do this. If you think 1 or -1 is a root, you can maybe go ahead and do that. Or if you feel like you have some intuition, you can give that a try. But we're going to do this just to keep us in shape with this, rational roots business. So our factors of 6 are ±1, ±2, ±3, and ±4. And ±1, ±3, ±9. So all our possible rational roots are all these numbers, or over all of those. So we're going to have ±1 over 1, ±1/2, ±1/3, ±1/4, ±3 over 1, ±3/2, ±3 over 3, which is 1. Actually, we don't need to write that because we already have written ±1, and ±3/4. Then we bring the 9, so we got 9 over 1, ±9 over 2, ±9 over 3, which is 3, and we already listed that, so we don't need to list it twice, and then ±9/4. Whew, that's a lot of possible rational roots. Hopefully we're not going to have to get down to these 9/4, but at least we have a finite number. We don't have an infinite number, which is what we would have if we didn't do this. All right. So then we're going to test some. So I'm going to test 1 because it's nice and easy. And I get 6, take away 11, minus 24 plus 9, and I can already see I don't have too much negative, not enough positive. That's not equal to 0. So therefore, x minus 1 is not a factor. Okay, so I'll try p of -1. I don't think this is going to make any difference either, but let's just double check, because I can always be wrong. So it gives us -6 minus 11 plus 24 plus 9. Okay, that didn't change much. I still don't have enough negativity to make up for all this positivity, so that's not equal to 0 either. So therefore, x minus 1 plus 1 is not a factor either. All right. So we're going to move on. And so this is one advantage of the rational zeros theorem. I can skip 2. So I'm going to move on to 3. All right, so 6 times 3 cubed, which is 27, minus 11 times 9, minus 24 times 3. 24 times 3 is 72, because 72 hours is in 3 days. All right, and so, 6 27s is the same thing as, I don't know what that is. I think 6 27s, so 3 27s, oh man, 2 27s is 54. Okay, it's 162. Okay, minus 99, minus 72, plus 9. This might actually work out. I'm not sure, but it's looking pretty good. So 162 minus 72, that's 90. Plus 9 is 99. Okay, that works. So therefore, x minus 3 is a factor. So then we're going to go to, so wait, I should take a second to say, therefore, x cubed minus 11x squared minus 24x plus 9 is equal to x minus 3 times something. Something. But what? So to find that something, we're going to use long division. We're going to say, well, x minus 3 is going to go into 6x cubed minus 11x squared minus 24x plus 9. I'm going to do this one really quick, so it's 6x squared, 6x cubed, take away 18x squared, subtract, it's going to give me 7x squared minus 24x plus 7x squared minus 21x. Take that away. And it's going to give us negative 3x plus 9. And x into 3x is negative 3. Not even really talking through this at all. What a terrible video. And we get 0 remainder, which makes us happy. 0 remainder. Happy days. All right. So that means that is the something inside here. So we're going to go a step further then, and we're going to say, okay, that means 6x cubed minus 11x squared minus 24x plus 9 is equal to x minus 3 times 6x squared plus 7x minus 3. And I can go one step further. I can factor this. I can think of two numbers that add to 7, hopefully. Actually, maybe not. And two numbers that multiply to negative 18. That's 9 and negative 2. Yeah, 9, negative 2, 9 and negative 2. So I'm going to say, okay, well, that means I've got 6x squared plus 9x minus 2x minus 3. I'm going to factor 3x out of these guys and leave 2x plus 3. And a negative 1 out of those guys, leave 2x plus 3. And so that gives me 2x plus 3, 3x minus 1, and x minus 3. That's all equal to 6x cubed minus 11x squared minus 24x plus 9. Okay, so the roots are x equals 3, negative 3/2, and 1/3. So I'll sketch those nice and happily. Hope I don't get some sort of catastrophe where my y-intercept doesn't work again. And negative 3/2. And we go up, down, up. Is my y-intercept positive? 0, 0, 0, 0, 9. Yeah, it is. Okay, I'm happy. That's at 0, 9. Great. So we have a little graph here of our polynomial. Whew. Okay, let's look at the last example, guys. And let's get out of here. All right, so I'm going to write the last example right here. So No, I will not have it open. Alright, the last example right here. For C. That's 8:30. I need to get out of here. Alright. Okay, quickly. Alright, so 2x cubed plus 3x squared minus 12x plus 5. So all the possible rational roots. So it's going to be plus or minus 1, plus or minus 5, plus or minus 1/2, plus or minus 1/5. Alright, so I'm going to test 1. 2 plus 3 plus 5, no, not equal to 0. Therefore, x minus 1 is not a factor. P of negative 1, this is where my penmanship is going to go downhill because I'm going to try and go through as quickly. So I'm going to get negative 2 plus 3, negative 2 minus 12, negative 4. Oh, wait, so negative, oh, God, okay. Negative 2 plus 3 plus 12 plus 5. That's not equal to 0 either. Therefore, x plus 1 is not a factor. Okay. I really don't want to try fractions, so I'm going to try my 5s. P of 5 is equal to 250 plus 75 minus 60 plus 5. Well, that's not going to equal 0. That doesn't work. So therefore, x minus 5 is not a factor. Okay, what about P of negative 5? So that's going to give us negative 250. This isn't going to work. Plus 75 plus 60 plus 5. Well, that's still not enough to counteract 250 negative values, so that's not equal to 0 either. So therefore, x plus 5, that should say 5, not 15, is not a factor. Haha, this sucks. Now we have to try a fraction. All right. But at least we don't have to try all these other numbers between 1 and 5. All right, so let's try p of 1/2. That's nice and friendly, maybe. So we get 2 times an 1/8 plus 3/4 minus 6 plus 5. Okay, this better work. All right, so 2/8, that's 2 times an 1/8 is 1/4. Oh, thank heavens. Plus 3/4 is 1. Take away 6 is negative 5. Plus 5 is 0. So therefore, the root 2x minus 1 is a factor. Ha! That's great. Okay. So, therefore, 2x cubed plus 3x squared minus 12x plus 5 is equal to 2x minus 1 times something. And we don't know. So we're going to go into long division now. And I'm going to go through this really quickly. I'm just going to mumble to myself, and you can listen if you want. I'm always going to make mistakes. I'm going to try to catch them as I go. 2x squared minus 2x squared cubed minus... I'm also going to make sounds every now and then. So you can listen in for that. Stay tuned. Well, this isn't looking good. X squared minus... There we go. Plus 4x. It's the end of the day, folks. My partner doesn't like it when I pronounce it folks. She says it should be pronounced folks. And I must say, she has a lot of support in this area. Most people disagree with my pronunciation of the word folks. But you know what? I'm going to stick with it. And then lastly, negative 5. Okay, we're almost there. Negative 10x plus 5. And they're the same. So we have 0 remainder. And we're happy. Sideways. Alright. It's starting to get weird, guys. So that means our 3x, our original polynomial, is really equal to 2x minus 1 times, and the mystery number is x squared plus 2x minus 5. Now, I need to factor that, but I already have a feeling that can't be factored. It looks a little funny, so I'm going to just test my discriminant here really quick. And I'll say 2 squared is 4. Take away 4 times a, which is 1, and b is -5, and I get 4 plus 20 is 24. And that's fine, but it's not a perfect square. So that means I can't square root it, which means this is going to have ugly roots. So which means I'm going to need to use the Pythagorean theorem, the quadratic formula. So that means that x is going to be -2 plus or minus a square root of 24, which I already found, over 2, which is say x is equal to -2 plus or minus 4 goes into that, so it's going to be 2 root 6 over 2, which is to say x is equal to -1 plus or minus root 6. Okay, so those are 2 of my roots. So the roots in total are 1/2, -1 minus root 6, and -1 plus root 6. And I need to put those on a number line somewhere, and that means I need to think pretty hard about where those numbers are. I can say -1 take away root 6 is right here. I'm almost done, Bryson. -1 plus root 6 is right here, and 1/2 is here, and I may be kind of wrong, and that's just the way she goes. And there we go. Let me know if you have any questions.